Very good morning. Welcome to BYJU'S Exam Prep. And welcome back to all of you for this particular C programming course. We already completed 10 sessions, and in today's session we are going to discuss about storage classes. Am I live? Hi, good morning, Arshpreet. Very good morning. Welcome. Yeah. So we had a long weekend. Hopefully you all practiced the problems which we discussed and reviewed the concepts which we discussed earlier. So let us start with the next topic, my dear friends. And today's topic is storage classes, one of the important concept for GATE point of view or for interviews point of view, my dear friends. Okay, storage classes. And this is about me, myself, Sridhar Sir. I am having 20 plus years of teaching experience, and you all know about me. And this is your Telegram group link. Hi, Navneet Sinha. Very good morning. Very good morning. Good to see new people. Okay, and in this Telegram group, we'll be sharing the class notes. Also, we'll have regular, questions, practice questions, weekly assignments. So please do join this particular Telegram group for preparing for your GATE examination, my dear friends. Okay. Now let us start today's class, my dear friends. Okay. And today's class is about storage classes. First of all, memory organization or memory layout of a C program. For that, we need to understand one important idea, that a running program is called process. And when you run any C program, its executable image is loaded onto the RAM of the computer in an organized manner. So the executable image will be loaded not in random manner, sir, in an organized manner, and that is what we call it as process address space or memory layout. So that executable whatever image is there, that will be loaded in an organized manner. We call it as memory layout. So let us, hi Manoj, welcome. Let us try to understand what are the different parts in that particular memory layout. Okay. See, it is not to the scale, just for our understanding purpose, my dear friends. Am I clear? And process address space or memory layout is organized into 4 areas of memory. Okay, we typically organize it, that is, this particular executable image will be typically divided into 4 areas. And the first one is called code segment, where your code is stored. We'll discuss each and every one in detailed manner, my dear friends. Second one is data segment. And there is some more space where we store these environmental variables and command line arguments. Even we have some space devoted for that. Okay. And the next one is stack segment. See, whenever you call functions repeatedly, what happens? The stack, for each function, one activation record is created and that is pushed onto the stack segment, my dear friends. Then comes heap segment. When you create the, variables using pointers, dynamically allocated memory will be stored under this heap, my dear friends. So these are the 4 main areas, okay, in which the executable image is stored in the main memory, my dear friend, or RAM. Am I clear? So these are called stack frames, and this is dynamic memory. Heap segment is dynamic memory. Let us understand each and every one in a detailed manner. What is this code segment? See, the code segment contains the executable instructions of your C program. That is code, the code portion. It is only read only, sir. We cannot change it, my dear friend. It is read only memory. Am I clear? And usually text segment is read only to prevent program from accidentally modifying its instructions. So it is read only. We cannot change it during the execution, my dear friends. Am I clear? So that particular portion is called code segment. So there is some portion when the executable image is stored, there is something called code segment where your text is stored in a read-only manner. Am I clear? The next one is data segment. See, data segment will have 2 parts. One is called initialized data. Suppose you create any variable and you initialize, that will be stored in this particular initialized data. It contains both static and global data that are initialized with non-zero values. So whatever static variables or whatever global variables which are initialized. Say, for example, static int a is equal to 10. So they are initialized. Even global variable which are initialized, like you create a global variable int a10 or int a50. So all those are stored in this particular initialized data segment. That is, this data segment will be divided into two parts. One part will store the initialized data, the other part will store automatically the uninitialized data, my dear friends. Am I clear? Uninitialized data, we also call it as BSS segment. So BSS stands for block started by symbol. BSS stands for block started by symbol, my dear friends. So it contains all global and static variables that initialize to 0 or do not have an explicit initialization. Simple, sir. See, there is a code segment where code instructions are stored. There is a data segment which is divided into two parts. One part where the initialized global variables or static variables. We will discuss what are the static variables in today's class, sir. Global variables and static variables are stored. Whereas one more part which is called uninitialized data segment or BSS segment, where the initialized global variables which are initialized to 0 or which do not have explicit initialization, no, those fellows will be stored in this uninitialized data segment, my dear friend. That is, this part is divided into two parts. In one part initialized data, in another part uninitialized data or BSS segment will be stored. Am I clear? Now comes heap segment. We'll discuss heap little later because we haven't started pointers. Once you start pointers, then you understand this heap segment in a more better manner, my dear friends. Am I clear? Everything in heap is anonymous. Am I clear? They will not have a specific name or it's anonymous. Okay. So you can only access parts of this through pointers. You cannot directly access it. You have to access that through pointers, through addresses. You cannot directly access that particular heap memory, my dear friends. Am I clear? The heap segment is an area where dynamically allocated memory resides. So we have to dynamically, at runtime, you have to create that particular memory. Am I clear? So we create this particular memory dynamically, my dear friends. Am I clear? Allocated by these functions. There are some beautiful functions like malloc, calloc, realloc, and of course, if you are doing C++, there is a function called new will be used for creating this memory in heap, my dear friends. Am I clear? And a memory is allocated on heap, the process address space. So as you allocate the memory in heap, the process address space grows, my dear friends. And the most, it is a typical, generally, of course, it is not to the scale, it depends on the architecture, my dear friends. In a typical architecture, this heap may grow upwards. So it may grow like this. Am I clear? That is about heap, my dear friend. Next comes stack segment. See, my dear friend, stack segment is very important. Am I clear? If you want to understand recursion also, the stack segment will help you a lot. Am I clear? Even in algorithms also, when you want to talk about space complexity, this stack segment idea is important, my dear friends. The stack segment is where local variables are allocated. So whenever you create any function, in that function you create some local variables. So that is where the memory for those local variables will be allocated in that particular stack segment, my dear friends. We will discuss in more detail this stack segment now. In C program, local variables are variables which are, see, whatever is within this block, they are called local variables. Okay, within a function, or you create within a program part, you create a block. So all that we call it as local variables. The variables within this block are called local variables, my dear friends. When we call any function, the stack frame created and pushed onto the stack segment. So what happens whenever you call any function, that is you call a particular function. Obviously, you give a definition for a function, and from your main program or from some function, you call a function, an activation record is created for that particular function. I'll tell you what are the different contents of activation record now in a while. Okay, let us see that. When a function returns, that is once the function activity is completed, whatever is pushed onto the stack, that is popped out of the stack, my dear friend. That is LIFO manner. Stack means LIFO. What is LIFO, sir? Can anyone tell what is LIFO? Can anyone tell me what is this LIFO? Sorry. LIFO means last in, first out. So whatever the last one is pushed, that is the one which is going out first. Last in but first out. Stack will be operating in LIFO manner, last in first out manner, my dear friends. Okay, very good, ADDY. Yeah, very good. All of you doing rocking. Okay, now stack stores one activation record. We'll try to see with one example. I'll show you a beautiful example where when you create a function, how an activation record is created and pushed onto the stack. We'll try to understand with a simple animation. Stack stores one activation record for each currently active function. So whenever a particular function is active now, for that an activation record is created and it is pushed onto the stack segment, my dear friends. Very good. All of you are giving beautiful answers, sir. And heap, as I told you now, it stores dynamically allocated memory. We haven't discussed pointers. After completing recursion, we start with pointers, sir. Mostly by last class of this particular week would be, last two classes would be this heap, pointers, my dear friends. Pointers are very important, and we discuss pointers in a more detailed manner. There we'll try to understand this, how this dynamically memory is allocated for pointer variables. Am I clear? Generally, stack and heap grows in opposite direction, my dear friends. So generally they say heap grows from bottom to top and stack grows from top to bottom. But whenever you try to show what is stack, we'll just show it like this, my dear friends. We just say that stack grows like this. It is only the image, logical image we try to give. Okay, so actually stack may be growing like this, but instead of showing it like, every activation record added like this, you may show it like this. Am I clear? Just try to understand the logical idea. Don't try to get into exact architecture, because it may vary from architecture to architecture also. So we are not getting into more physical view, my dear friend. Mostly here we are talking about the logical view only, or logical understanding only. Am I clear? Please try to understand that. But generally, stack and heap grow in opposite direction. Generally, heap grow from lower address to higher address, and stack grows from higher address to lower address. That is how it happens. It is for a typical architecture, it happens. Am I clear? Don't ask me which architecture it happens. I do not know that particular information. Okay, you can browse that. Now, activation record. My dear friends, data needed for activation of a function is collected in a record. That is, you want to activate a particular function. You want to call a particular function. So whenever you call a function, whatever data needed for that. See, data needed for that means you are sending some arguments to it, and that particular function may be calling some other function. So when it is going, when you call a particular function, for example, I am having a particular function F1, sir. I am having a particular function F1, and suppose this is calling F2. So when it is calling this F2, you should store the machine status at that particular point and return address. Means after completing the work, where you should come back, that all to be stored, my dear friends. Okay, so let us see what are the different content to be stored when a particular function is created, and that particular content is stored in what is known as activation record. They are all stored in what, sir? Activation record, my dear friends. Data needed for activation of function is collected in a record called activation record, or simply people call it as stack frame, my dear friends. People also call it as stack frame or activation record, my dear friends. Content of activation record includes different content. What are the different content which are included in activation record? I'll try to put it in a very simple sense here, my dear friends. Intermediate results that arise in evaluation of expression. Suppose you have an expression, the intermediate results will be stored. Temporaries we call it. Then local variables, local data. Whatever local variables you are going to create, the memory for them will be created within that activation record. Saved machine status, the status of machine before the function call. Suppose within the function you made a function call. So before the function call, what is the status of that particular machine? Okay, and return address means after completing the activity of function, where you should return that particular information. That is generally called as saved machine status. Access static links refer to non-local data held in other activation records. Okay, some non-local data which may be in other activation records, it may be referring to links, we call it access links we have, that may be stored in this particular activation record, my dear friends. Control or dynamic link, it points to activation record of the caller. So we should also, the address of activation record, the link of the activation record is also stored in this particular, the one which is calling this, that fellow's information also stored here, my dear friend. Link. Parameters. Because when you call a function, obviously some parameters are passed, am I clear, or actual arguments. So the actual arguments passed to the function are also stored in formal parameters, my dear friends. And finally, return value. After completing the story, what is the value it has to return? So these are all information which are stored in activation record, my dear friend. Means whenever a function is called, lot of information is stored. In a simple sense, I just given all those informations which are stored in activation record, my dear friends. Am I clear? When a function begins execution, that is activated, an activation record, or also called as stack frame, is created to store the current environment for the function. So simply, activation record means what, sir? Whenever you call a particular function, what all the information needed for executing that particular function will be stored in the activation record, my dear friends. Am I clear? In a simple sense, that is the story about activation record. Now let us see this. When a function is called, push a copy of activation record onto the, when a function is called, push a copy of its activation record onto the runtime stack. The top activation record in runtime stack is always that of the function currently executing. Because suppose you call a function that calls another function that calls another function. So you may be having main function. Obviously, first main function activation record is created. Main call another function, that fellow's activation record is created. This function called another function, that fellow's activation record is created. So on the top, which activation record will be there, sir? On the top, which activation record will be there? See, the top activation record in runtime stack is always that of the function currently executing. Whatever the function currently executing, that will be on the top of the activation record or top of the runtime stack, my dear friends. Am I clear? One second. All of you able to follow? Anyone having doubt? Clear to you all? Sir, does it mean that when a function is called, the first item fetched from stack are? See, it does not mean that order, my dear friend. They are all, it is just a particular diagram. What are the information stored in activation record? See, I am not saying a physical diagram. I already told you it is a logical picture only, not physical picture, my dear friends. Okay. The information is stored. How it is stored exactly, I do not know. That you need to ask. Okay. Maybe you need to work with a particular operating system or a particular architecture, my dear friends. Okay. What I mean is, when a particular function is called, the activation record of the function is created, and in that activation record, all this particular information will be stored. All this information will be stored. That is what we need to understand. It is not the physical order, my dear friends. It is not the physical order. It is just a logical order. It is just a logical order. Please try to understand. Don't get into exact picture. It's not like that. Okay? No. Let me clear this. Now, for example, now look here. First, obviously, the execution begins from where? Execution begins from where? Main function. The activation record of main function is pushed onto the stack. And again, I told you, if you observe, there are different segments. There is a code segment, there is a data segment, and some space for environment and command line argument. And this is stack segment. The stack segment may be growing like this in your lower address to higher address. But logically, I am just showing it like, the activation records are pushed onto the stack like this. This is just a logical view, not a physical view. Please try to understand that point, my dear friends. It is just a logical view, not physical view. Okay? Please try to understand. Now look here. First, activation record of main is pushed onto the stack. Okay? Suppose main called another function, say F1. The activation record of F1 is pushed onto the stack. So in that particular activation record, all that information needed for execution of that particular function will be stored. Like temporaries are there. There are so many information that are there, no? Saved machine status is there, local data is there, arguments are there. All that will be stored in that particular activation record. All that information is stored in that particular activation record. Now this function F1 calls another function, suppose. the activation record of F2 will be stored, pushed onto the stack. So what will be on the top of the stack, my dear friends? What will be on the top of the stack? The function which is currently executing is on the top of the stack. The function which is currently executing is on the top of the stack. Suppose once the activity of this particular function is completed, what happens, sir? What happens? When a function terminates, the activation record is removed, my dear friends. The pop activation record of terminated function from runtime stack. That is the top of the stack, whatever activation record is there, that is popped out. Am I clear? So it is popped out. So F2 work is done, the activation record is removed. Now F1 work is done, activation record of that is done. Now your program terminates, means your program is completed. The main activation record also will be popped out, my dear friends. Yeah, popped from stack. Simple logic. Am I clear? So this is the logic, my dear friends. Okay. So what we do is, let us try to understand with one example. Before that, the order of return from function is reverse of the function invocation. We already understood, no? The order in which the function's activation record is pushed onto the stack is reverse. When you pop out in the reverse order, that is the last activation record which is pushed onto the stack is the first one which is popped out of the stack. Am I clear? Okay, therefore use a stack to store the activation record, because the last function has to return, because after completing the activity of the function is completed, we have to throw it, then only we have to go back to the previous one. Because of that they use stack. See, the logical idea is same, because main is there, the activation record you stored, main called a function, the activation record of that particular function you stored. Okay, see which one we have to remove first, main or this fellow? The function which is called later should be removed first, because this activity is completed, you have to remove it. So logically the best data structure which can be used for calling sequence of functions is runtime stack, my dear friends. That is what he is trying to say. Since stack is manipulated during runtime, we call it as runtime stack. Why it is called runtime stack, sir? Because during the runtime it happens. The activation records are created and pushed onto the stack and they are removed from the stack. We call it as runtime stack. Am I clear? Activation record of main is created, pushed onto the stack. Then you call a function that is pushed onto the stack. Then you call a function 2 that is pushed onto the stack. Function 2 activity is completed, pop it. Function 1 activity is completed, pop it. Main function activity is completed, pop it. So let us try to see this entire story with this simple example, my dear friends. Okay, let us take a simple program. Let us see. Of course, there are so many other information stored in activation record. What we are interested in is the local data. That particular thing we try to understand, my dear friends. Now look here. Here main function, we have a local variable which is a. Local variable which is a is equal to 3. And you are calling function f1. Calling function f1. So at this particular point, control moves to function f1. Am I clear? Control transferred to f1. And here what you are doing, printf, but here you are calling f2 function, means the control transferred to f2, my dear friends. And in this you are calling f3 function. So the control moves to f3. Now what happens here, my dear friends, once this f3 activity is completed, the f3 part is done. So you have to remove the activation record of f3, then you come back here. Am I clear? Then this particular assignment will happen. Then what happens? You are doing return. Once return is happening, it move back here, because here the printing will happen, then return will happen. Once the return is seen, you move back here, then the remaining statements are executed in sequential manner, my dear friends. So this is how the execution happens. So let us see how the activation records are created. Now look at this. Main begins an activation record for it is created and pushed onto the runtime stack. The main function activation record is pushed onto the stack. So in this particular thing, what is stored, sir? A is equal to 3 is stored. What you can say, A is equal to 3 is stored in that. That is local variable. The local data is stored. Now what is happening, sir? You are calling F1 function. When execution of main is interrupted by function called F1A, an activation record for F1 is created. So activation record for F1 is created. In this, there are no local data, but this argument will be stored. That is, X will be stored. Am I clear? X will be what, sir? Whatever value you send, that will be stored in this particular X value, my dear friends. Of course, saved mission status, all other stories will be there, but we are not interested in this case. Okay, we are only interested in the execution of function, and what about the return values? We are only interested in that. We are not interested in rest of the story, my dear friend. Activation record means what all needed for execution of that particular function will be stored in that particular activation record, my dear friends. Am I clear? Like, now when execution of F1 is interrupted by F2, the activation record of F2 is created and pushed onto the stack. So in this F2, what happens? Of course, this P is there and there is a local variable Q is there. That Q data will be stored in this, my dear friends. Am I clear? Now when execution of F2 is interrupted by function call F3, an activation record for F3 is created. Now activation record of F3 is created. Here in this F3 also, there are no local variables, only this argument parameter is there, that will be stored, my dear friends. Am I clear? So once this activity is completed, whatever value you send, no, that particular activity, what it is going to return, sir? N into N plus 1. Suppose 2 is sent, 2 into 2 plus 1. 5 it returns. Okay, like that. So if you want, you please trace what this particular function is going to return, my dear friends. I want all of you to work and tell me what this particular function is going to return completely, totally. Finally, what is this particular function is going to return? Is it going little slow? Okay, fine. Is that clear? Hope you understand. So here A is equal to 3, you call F1 3. What do you call? You call F1 3. So this X value is 3 and you are calling F2 3 plus 1. That is, you call F2 4. You call F2 4. And here P value is 4. And what you are doing, you are calling F3 4 by 2. 4 by 2 means 2. This is 2. So you call F3 2. F3 2 means 2 into 2 plus 1. That is 5 is written. It returns 5. So Q value will be 5, my dear friends. So this is written. What is the value written? 5. Q value will be 5. I think it should be 2 into Q, sir. Otherwise what happens? It will not execute because it will show an error. It should be 2 into Q, sir. It should be 2 into Q. So 2 into 5, 10. 10 is written here, my dear friend. 10 is written. Am I clear? 10 is written. Hope you understand. Now 10 is printed here and then it returns. And that's it. So output of this particular program will be simply 10, my dear friends. Of course, there is a printing error. Please correct that. That is, it is Q, not A. Because A it does not know, because A is not even a global variable. So this local variable information this fellow do not know. Am I clear? Very good morning, Vivek. Very, very good morning. Hope you understand. So this is the execution process, my dear friends. So whenever a function is called, its activation record, which stores the information needed to execute the function, stored in that particular activation record. Generally local data, formal argument, mission status, saved mission status, all this information will be stored in the activation record, my dear friends. Of course, it also will store return value, what is the value to be returned, everything. Am I clear? Which part you want me to explain once again, my dear friends? The program execution or this part? Abhay, which part you want me to explain once again? Okay, let me explain this program execution only. See, my dear friends, this is the idea. Simple. And please correct this. This is Q, sir. This is not A, it is Q. See, no problem, sir. See, practice generally practice is required to understand or to review the ideas. Am I clear? If you are very confident, don't do practice, sir. Okay, if you are very confident, don't do practice. Suppose you are not confident, you have to find some time. Okay, you have to make an alternative to do the practice things, my dear friends. It is compulsory for everyone. If you are very confident with your concepts, don't do practice. Okay, that is generally illegal, my dear friends. See, I'll tell you one simple logic, my dear friends. We generally understand things with our short-term memory. We understand things with our short-term memory. and whatever is written on short-term memory will be erased soon. Okay, if you don't practice it, it won't go to long-term memory. And whatever is in your long-term memory, it will be stored for long time and you can reproduce it or you can reuse it. Short-term memory means your short-term memory is very good. When a faculty, teachers or anyone explains, you will understand and you answer things very quickly. Good. But that is only for short-term. If you don't practice, it won't be stored in your long-term memory and it cannot be reused, my dear friends. Am I clear? See, it's not about that. What happens? Whatever is stored, suppose there is a formula is there, minus b plus minus root b square minus 4ac by 2a. Suppose this formula you want to know it. This will be stored. Suppose you are good, immediately if I give you any problem, you solve it. But later on what happens if you don't practice it, this will be erased. See, if it is completely erased, no problem. You know how it will be erased? It will be erased like this. Something like this, it will be erased. So you can see that image, but you are not able to reproduce it or you cannot able to completely recollect that particular formula. So there is something like, you know, whether it is 2 or 4, whether it is 2 or 4, this kind of doubts you will be getting it. This kind of doubts you will be getting, my dear friends. So this is the problem if you don't practice it. Okay? Okay. Yeah. Please try, sir. It is possible for everyone. Now let me answer the, you know, Abhay. Sir, Abhay, see this. Yeah, Abhay, see this. Okay. Now look here, sir. You call main function. This should be Q, sir. You call main function. Its activation record is created and pushed onto the stack. So in the main, what is there? Only a variable is there and the value of that is 3. And you call this particular function f13. That is, what is the function you called, sir? f13 you called it. f13 means this x value, that is this f1 is created means its activation record is pushed onto the stack. f1 is not having any local variables, but this particular parameter is there, no, that will be stored here. X value will be what, sir? Whatever you send, no, that x value is stored here. Now here this fellow, it is calling f2 x plus 1. What is x, sir? X is 3, 3 plus 1, f2 4. It calls f2 4, my dear friends. So f2 4 means this f2 4, this particular function is called, and that fellow's activation record is pushed onto the stack. So here p value will be 4, my dear friends. And here there is a local variable which is q. And what is the value of this? For that you are calling f3 p by 2. What is p, sir? 4. 4 by 2 means 2. So it will call f3 2. What is called? f3 2 is called. So this n value, that is f3 means, f3 is called means its activation record is pushed onto the stack, and this is n value, sir. What is n value here, sir? 2. And what it is doing, sir? It is not doing, it is not having any other information, only n into n plus 1 it is doing. That is 2 into 2 plus 1. And you all know that the precedence of operators, this is executed first, 2 into 2, 4 plus 1, 5 is returned by this particular function. So this particular function just returns 5 to this f2, my dear friends. And that 5 is stored in what, sir? That 5 is stored in what? That 5 returned by this particular function, that 5 returned by this particular function is stored in Q. So what happens? Q will get the value of this. So by this time f3 is popped out. f3 is popped out. Am I clear? Now this Q value is 5, and what it is returning, sir? It is 2 into 5 it is returning. That is 10 it is returning. It is returning 10. And that returned value is not stored anywhere, sir. It is just printed. Whatever value you send back, na, that is just printed by using this conversion specification. So what happened? The 10 is printed. So f2 is gone, and this here some printing story is happening now. So that printing of 10 will happen. So only 10 is printed, my dear friends. Then what happens after that? It returning without returning any values, just because it is void function, it is not returning anything. Blindly it moves here, my dear friends. And again after that there is no activity, just return. Means main function also moves out, my dear friends. So this is what actually happens, my dear friends. Hope this is clear. Yeah, that's it. It's very simple process, my dear friend. Whenever a function is created, the information needed for execution of the function is stored in this particular activation record, and that is pushed onto the stack. And what will be on the top of the stack, sir? The function which is presently executing will be on the top of the stack. That's it. Simple story. Nothing more than that. Now we actually start our story, that is storage classes. Okay, now we start with storage class. So we should know, activation records are created where the data will be stored, because whenever your function is created, the local data will be stored in the activation record. The local data will be stored in the activation record. Okay, see, ultimately whether it is activation record or whatever it is, where this computer store data, where the computer store the data when you are executing a particular program, my dear friends, they store the data either on the main memory or on the CPU registers. Okay, either on the memory, RAM or CPU registers. Memory inside processor, my dear friends. And memory, main RAM memory compared to two CPU registers, it is a slow memory, and obviously the register memory is the fastest memory, my dear friends. And RAM compared to CPU, it is lots of memory, but we have limited number of registers, so this memory is limited, my dear friends. This memory is limited, my dear friends. So where when you are executing a program where that particular data will be stored either on the memory or on the CPU registers, my dear friends. Am I clear? Now the storage classes will tell you what is the type of data, what is the lifetime, what is the scope, where that particular data is stored, what is the initial, all that particular information is given by this particular storage classes. Am I clear? So let us understand the storage classes, and one of the important concept, whether it is for gate point of view or whether it is for interviews point of view, this is one of the important concept. People definitely ask this question, my dear friends. See, okay, yeah, Shiv, you can just send a message, we can discuss, sir. Shiv Modi, you can, this is my Telegram group link. This is my Telegram group link. You can connect me, and personally you can ping me. In that you can find my name. You can personally ping. We can discuss more about it. Okay, Shiv Modi. Okay, yeah. See, in addition to data types, see when you create like int a, this is a data type. In addition to type of data, each variable has one more attribute known as storage classes. Is known as storage classes. The proper use of storage classes makes our program efficient and fast. So if you use the storage classes proper, your program will be efficient as well as fast, my dear friends. Okay. So why we require storage classes? Because storage classes decides about four aspects of the variable. First one is storage. Where it is stored. Where it is stored, it will tell you. Whether it is stored in memory or registers. Of course, even registers they mention, because registers are limited. Even if you forcefully mention like register storage, if it is not available, obviously that will be stored in memory only, my dear friends. So mostly the data will be stored in memory only when you are executing. That is, when an executable image is stored, it will be stored on the memory only. But sometimes you can forcefully do by saying register variable. Okay. But generally people say that is a old style. Now no one write that register separately, my dear friends. But that is one more register class which is available in C programming language. Because C programming runs very close with machine, these facilities are available in C programming language, my dear friends. Am I clear? We need to know about it. So what it will tell, storage class will tell you where it is stored, the place where the data is stored. Second thing, the initial value. Suppose if you not initialize the value, what is the default value? Whether it is garbage or 0, it will tell you. The storage class will tell you that. And the third point it will tell you is scope. Scope in the sense where this particular, the part where you can access this particular variable. That is the range of statements over which it is visibility. Okay. The scope will tell you mainly about the visibility, where this particular variable is visible. See, visible means then you can access it, you can use it. If it is not visible, you cannot access it. Simple. See, temporary storage or temporary caching, yeah, you can say that, my dear friends. Next, life means how long that particular. See, sometimes variable may not be visible, but it is still alive. Am I clear? So that is what we need. How long that particular variable is bound to that particular memory cell. So there are something like static variables, okay, and there are something like global variables. So these people, okay, these variables are available throughout the program. Am I clear? They persist between functional calls. So their life is throughout the function, but they may not able to access, you may not able to access them in some parts of the program. That we need to understand. So storage classes tells you four important things. What is the first one? Where it is stored. What is the second one? Initial value, whether it is garbage or zero value. Sorry. Okay. I make like garbage or zero value. Second point. And what about the third point? Scope, visibility it will tell you. And the fourth important point, it will tell you life. See, life means how long the variable is available. See, at some places variable may not be visible or it may be dominated by some local variables. Am I clear? But life means how long it is available. So all these four informations are given by storage classes, my dear friends. Am I clear? Now there are four storage classes, my dear friends. The first one is automatic. Default, if you don't give any storage class, by default any variable is auto variable. Any variable which is defined within a block or a function is automatic variable, my dear friends. Register variable. See, sometimes some variables are used very often. Very often you are going to use. Am I clear? So generally what we want is you want to store them in this register variables forcefully. Am I clear? So that is register variable, my dear friends. And the third one is static variable. This is very important, my dear friends. Static variable you have to understand properly. See, these are not natural, my dear friend. Automatic and register are very simple. You can easily understand. There is nothing in that. But what we need to concentrate is the static variable. And we need to also note about this idea of external variables. Out of this static variable is very important, my dear friends. Am I clear? The static storage class. Choosing a storage class. See, generally auto is default storage class, my dear friend, and used in most of the cases. Register variable is accessed more frequently. Suppose if a variable is accessed very frequently, very often, then we generally try to force it as register variables. But now people say it is old fashioned, so generally people don't use this register storage class most of the time, my dear friends. Am I clear? Most of the time people don't use it. They call it as old fashioned way of defining the variables. So generally register people don't use it, but that availability, that possibility is there in C language. You can call a particular variable as register variable. Am I clear? That possibility is there. Next one is external variable. Variable is required in all functions or whole program. See, these external variables you can also use in different files also, my dear friends. Properly including and properly declaring them, you can use in other files also. So these external variables are available throughout all the functions and throughout the program or in other files also. Am I clear? The next one is static. Variables value to be retained between functional calls. So if you want to keep the value of a variable alive, then you can define the variable to be static variables, my dear friends. Am I clear? See, these static variables are used, suppose some particular function is called very regularly. How many times the function is called? To count that, we use static variables, my dear friends. General purpose is for such kind of purposes. How many times the function is called? Am I clear? In such cases, we are going to use this static variable, my dear friends. Now, before actually getting into this storage classes, we need to understand these two variables. One is called local variables and the other one is called global variables. See, default local variables are auto variables and default global variables are external variables. Default any variable which is global we is considered as external variable, my dear friends. Okay. So first let us understand what is this local variable. Variables that are declared inside a function or a block are local variables. So any variable which is defined within a block or a function is called local variable, my dear friends. Memory is delocated upon exit from function or block. See, as I told you, activation record is created for a function when you call a particular function. And once the activity is completed, that particular memory is delocated. So memory is delocated upon exit from function or block. So once you move out of that particular block or function, the memory allocated for that particular variable will be delocated. Local variables memory is only as long as that particular block or function is alive. Once you come out of that, it is dead. Am I clear? Like that. Next one is global variables. Global variables are defined outside of all functions. Global means outside of all functions you define it, sir. Not within any block. They are free of blocks. They are defined outside. For example, hash include stdio.h. Here you may write int a. So it is global, outside of all functions, global variables. Am I clear? All functions in the program can access and modify. All functions can use it. Suppose if I call F1 and I have one more function F2, sir. Here I am having int A. Here also I am having int A. This A is different from this A, my dear friends. Okay. Suppose if you have some int A outside, this A can be accessed by this function. This A can be accessed by this function. So if you define any variable, if you define any local variable, that fellow can be accessed within that particular block or the function, whereas global variable can be accessed by every function, my dear friends. But sometimes what happens, even though you may be having global variable, you have a function where you have local variable with same name. Local fellows will have more preference than global fellows. Local people will have more preference over global. So here whatever A you are using, that is local A only, not global A. Am I clear? So the local variable dominates global variable. Suppose there is no A here, then A means this global A only. Suppose there is there is local variable and global variable, local variable get preference over global variable. Always remember that point, my dear friends. Am I clear? A global variable is available for use throughout the lifetime of the program after its definition. Once you define it, it is available throughout the life of the program. As long as the program is alive, this global variable is alive. Whereas local variable is having its life within the block. Once you come out of the block, it is dead. Is that clear? Now let us see the 4 storage classes in detailed manner, my dear friends. Of course, we need to know about all the 4 storage classes. Out of 4, the most important fellow is static. And there are many questions which are asked based on this static variable in GATE examination. Not only in GATE, any competitive examination, they'll ask you questions about static. Sometimes external also, they ask you good questions, my dear friends. Local variables, by default, any variable which is defined within a function or within the block are local variables, my dear friends, or automatic variables. And what is the keyword for this automatic variable, sir? Auto we have to use. Default storage class of variables declared within a block is auto. Even if you don't write auto, any variable which is defined within a block is default, it is auto variable only, my dear friends. Am I clear? It's a default storage. For example, you see this void main auto int AB, print AB, that's it. Now here AB are local variables and default they are automatic, my dear friends. For example, instead of writing this, even if you write int AB, see I written here only, sir. Here you see whether you write like this or whether you write like this, they mean one and the same, sir. So default int AB you are writing means they are automatic variables only. Default is automatic variables only. You don't have to worry about it. Am I clear? Default is automatic. And when they are automatic variables, okay, their storage is of course within that activation record, and the default value of this automatic variables is garbage value. Suppose if you run this particular program without initializing them, by default the value of AB will be some garbage, my dear friend. By default their value will be garbage. So initial value will be garbage value. So if you just print like this, you get some nonsense value, and don't ask me how that particular value you get it, because that is some garbage value which may be stored in that particular memory location already. We do not know. So that is garbage value, you call it. Am I clear? Look at this example. I am having a function. It's a prototype, sir. It is just a prototype. I am having a function. I am having a function which does not take any argument and which does not return any arguments. And this is the main function. From the main function, I am calling this function 3 times. Now this is the function definition, my dear friends. Int x is equal to 10 and y is equal to 5. So here x and y are 10 and 5 respectively, my dear friends. Now what happens, I am printing this particular values of x and y. I am printing the values of x and y, my dear friends. After printing, I am incrementing the value to 11, plus 1. That is x plus plus means x value is incremented by 1 and y value is y plus 10. That is y value is 5 plus 10. 5 plus 10 is 15, no? 5 plus 10 is 15. So this is what this particular function is doing, sir, nothing more than that. This particular function is doing this particular activity. Am I clear? Now when you print, what will be the output? Can anyone tell me what is the output, my dear friends? Please tell me the output of this particular program. What will be the output of this particular program? Yeah, Arshpreet says 1335. See Arshpreet, you need to understand this properly. See this carefully. Now look here, sir. From main you call this particular function. First time when you call this particular function, the activation record of the function is pushed onto the on the stack, runtime stack. X value is 10, Y value is 5. When you print, what is printed first time? 10 \t means tab character. Okay, x equal to 10 and y equal to 5 is printed. X is equal to 10 and y is equal to 5 is printed. After that, x value is modified to 11, y value is modified to 15. But this function is completed. This function is completed. So, this memory is removed. This memory is removed. So, this particular memory is erased, my dear friends. Okay, already what is printed, sir? What is printed? 10 and 5 is printed. X equal to 10 and y is equal to 5 is printed. And first time when you call this particular activity, x is 10, y is equal to 5 is printed. X value modified, y value modified. But once it is done, the values are erased. Now again you call the function. When you again enter, the value of x will be same 10 and value of y will be same 5. Again when you call it. And again what happens? X equal to 10 and y is equal to 5 is printed. That's it. Again when the function is called, what it is doing, sir? It will again start with the same values. Previous values it will not remember. That is deleted. That is deleted. See, it is like this, sir. You are having main function. Then function is called. In the function, x value is 10, y value is 5. And this particular printing is happened. Then x value is updated to 11 and y value is updated to 15. After that, this activity is completed. Means this part is erased, my dear friends. This part is erased. Means this particular memory is also erased. After printing this particular memory is erased. Now what happened? Again you call the same particular function. You call the same function again. Once you call again the function, again activation record of this function is pushed onto the stack. Now again what happened? X value is 10. Again in the memory x value is 10 and y value is 5. So what is printed here? Again x equal to 10 and y is equal to 5 is printed next time. Now again this particular activity is completed, that is x is updated to 11 and y is updated to 15. But the function activity is done. So what happened? This activation is popped out. So activation record is popped out means this memory is also gone. The memory allocated is deallocated. Now again you call this particular function. Again you call this particular function. Again activation record of the function is created. Means again memory for x is created in this particular stack only. X is 10 and y is 5. Again you print x value 10 printed, y value 5 is printed. Again x value is updated to 11, y value is updated to 15. But again this activity is completed. Again this activation record is popped. And again all this particular memory is deallocated. Yes. If you want to go inside a function, then how can we go? How you want to go inside a function, sir? If the incrementation comes before printing, suppose if you do incrementation before the function, then what happens? X will be 11 and y will be 15 will be printed. X will be 11 and y will be, suppose if you do this before this, x value is 11 and y value 15 will get printed, sir. That's it. See, inside the function, see, what do you mean by going inside the function, sir? You can call a function. If you call the function means automatically that activation record is created, you are inside the function. So whatever activity is there, that particular activity is run. Now once you reach the end of the function means this activation record is removed and this activation record is removed and the data, that is the memory allocated for the variable, that is also deallocated. So x and y memory whatever you created for this particular function, that is gone. Hope you understand like this. So when you run this particular code, what will be the output, my dear friends? X10 Y5, X10 Y5, X10 Y5. You call it 1000 times, same story will happen. As someone asked, suppose you write this increment of x and y value before the print. Every time what will be printed, sir? If you do this activity before printf, every time what happens, sir? X will be 11 and y will be 15 stored. X will be 11 and y will be 15. X will be 11 and y will be 15. Suppose if you do this before printf, my dear friends. Suppose if you do this before printf. Is the idea clear? Yes or no? Yes or no? All of you able to follow? Very good. Now look here, this is one more interesting part. See, suppose this may be a function, sir. This is a block. So when you start this particular block, suppose if it is a function, the activation record of that particular block is created or that particular function is created. In that a is the variable. See, even if you write int a, it is same as auto int a, sir. If you want auto int a, you can write, or simply int a, you can write it. Within a function, if you write int a, it is same as auto int a, my dear friends, even if you don't mention that. Please remember. Now look here, I created a small block here. Within this, I created a new variable b. And I assigned a value 15. See, this a, this a is global a. So, int a is here. Within that, you have any number of blocks. In that, this a is available, my dear friends. If you don't have local a, this a can be used inside all these blocks, my dear friend. That is, this a can be updated here. So, the memory for a is created and inside that, memory for b is created. A value is updated to b. But once you come out of this block, you cannot access b, my dear friend. It will pose an error because b is not known in the outside block. B is known only within this block, sir. So whenever you give any block, any variable defined within that block is available up to this block only. That particular variable is available. This cannot be used outside. So let me put this in a simple manner, my dear friends. The idea is like this. Suppose you are having an integer variable or whatever it is, and you have some block. A can be accessed in this block. Even if you have one more block, A can be accessed within that block. Suppose you have one more block, A can be accessed in this block, in this block also. Okay? Suppose if B is declared as global, then you can use it, sir. Suppose if this B is global, that can be used. That's what? The outside of the blocks, whatever is available, that is available throughout all the blocks. Whatever nested level you take it, that is available throughout that. But if you are having this and this int B, you cannot use B here. So whatever is inside the block, that cannot be used outside the block. Whatever is outside the block, that can be used inside the blocks. Whatever is inside the block, that cannot be used outside the blocks. This is simple logic, my dear friend, nothing more than that. If we declare B outside function, then can access, yes. If B is here, then you can access here and you can access here also. Suppose here if you write int AB, then you can access inside the block or outside the block. But if B is inside, this is not visible outside the block. Whatever is inside the block is not visible outside the block, sir. So let me give you, this is like this. Okay, I think, not that. This is like this. So this B is available within the block. Suppose there is one more block inside that, there B can be accessed. But outside the block, B cannot be accessed. Simple logic, sir. Now auto is default storage class. Where it is stored, where automatic variables are stored, they are stored in runtime stack activation record. Actually, in the activation record, this automatic variables are stored, my dear friends. They are stored in the activation record, runtime stack. Stack grows now. Obviously, stack, how it grows, sir? Activation record of the particular function is created. Inside that, this particular memory is created. Uninitialized. Suppose if you just say int a, what does it means? Its value is garbage. If you don't initialize, its value is garbage, my dear friends. Its value is garbage, my dear friends. Scope, within the block. Where it is defined within the block, my dear friends. Its scope is within the block or the function. Inside that block. See, inside that another block is there, no problem. See, within the block, whatever nonsense is there it is visible, sir. Not outside that. Am I clear? Function or block. That is within the curly braces in which it is defined, there it is visible. Outside that it is not visible. Life inside the block. That is, as long, suppose you got a function call now, as long as the function is alive, this particular variable is alive. Once the function is out, the activation record is out, the memory is also out. Am I clear? So that is about automatic variable, my dear friend. What is its storage? What is its default uninitialized value? What is its scope? And what is its lifetime? Storage is runtime stack. Default value garbage. Scope is within the block. Life is as long as you are in the block. That's it. That is about automatic variable, my dear friends. See, the automatic variables are named as automatic since the storage for them is reserved automatically each time when the control enters the function or the block. So each time when the control enters that particular function or block, automatically the memory will be created for those variables, my dear friends. Okay, and memory is also released automatically. Once the block or function terminates, the memory is delocated, terminates. Okay, so when you enter the block, automatically memory is created. When you leave the block, automatically memory is delocated, my dear friends. So that is about automatic variables, my dear friends. That is about automatic variables, my dear friends. Register storage class, just for information, my dear friends, we need to understand. The story will be exactly same as automatic variables. Only difference is automatic variables are stored in runtime stack. These are stored in registers if memory is available. If memory is not available or registers are not free, again it will automatically allocated to runtime stack only, my dear friends. Am I clear? Please note that particular point. Register storage class is like auto storage class, but the difference is here variables are stored in CPU registers, of course provided they are free. Provided that particular registers are free. Otherwise, same as automatic variables, my dear friends. Keyword is register. So we write like register int AB. Variables is stored in fast CPU registers, used when a variable is used more frequently. And since CPU registers are limited, note this point. If CPU registers are not free, the variable is treated as auto variable only. Suppose if CPU registers are free, the memory can be allocated, they can be allocated, sir. Otherwise, they are considered as automatic variables only. And generally, they mention that register is old method. Now they are not using it, my dear friends. So where they are stored, my dear friends, CPU registers. Of course, CPU registers, if not available, same as automatic variables. That is runtime stack only. Am I clear? Default garbage. Rest of the story is same as your automatic variables are. There is no specialty about register variables, my dear friends. Garbage or undetermined. Next one is scope within the block. And life inside the block. So as long as you are inside the block, this particular fellow is available. Once you are out of the block, they are dead. Same as automatic. See, there is no much difference between register and automatic variable. Only difference is if CPU registers are free, memory will be allocated in the register, sir. Otherwise, same as automatic variables, no difference at all. Just take one simple example. I taken same example, sir. Only thing is, same as the previous example, instead of auto, I just written register. If memory is available, this particular memory is allocated in the registers, but same story, sir. Same story as your automatic variables, no difference. Only thing is, instead of runtime stack, the memory is allocated in CPU register, my dear friends. Nothing more than that. So output would be exactly same as that. No difference between register and automatic variables except for where they are stored. Storage is different. Rest of the story is same to same. Rest of the story is same to same, my dear friends. Now comes external variables. See, by default, any global variable is external variable, my dear friends. Suppose if you want to use it, okay, within a function, by default, you don't have to mention extend keywords. See, generally people ask the difference between declaration and definition of a variable. They ask this doubt like what is difference between declaration and definition of a variable. My dear friends, in C language, by default, declaration and definition of variable will be same except for this extern. Only for this external variable, there is a difference between its declaration and its definition, my dear friend. For rest of the variables, declaration, for example, automatic variable, if you write int a within a block or a function, it is declaration, it is definition. Definition will allocate memory. Declaration will just tell you such a fellow is there. The difference between declaration and definition is declaration will tell you, okay, such a fellow is available. Definition means what, sir? Memory will be created for that. And by default, if you see automatic variables, whenever you create an automatic variable, okay, we know that type of variable is available. Memory is also created for that. Memory is also created for that. So by default, automatic variables, register variables, their definition and their declarations are one and the same. But for external variables, there is a small difference between declaration and definitions. Okay, we'll try to understand that now. Okay, let us see that. The variables that have to be used by many functions and different whiles can be declared external variables. See, my dear friends, these external variables are defined ones, can be declared many times, my dear friends. Am I clear? Means declared and you can use it many times, my dear friends. The initial value of an uninitialized external variable will be 0, my dear friends. The declaration of external variables declares the type and name of the variable. See, there is a difference between, for external variables, there is a difference between declaration and definitions. There is a difference between declaration and definition. We'll try to fix that now. Okay. The definition of external variable reserves storage for a variable as well as behaves as definition. See, definition behaves both as definition, that is storage will be created, and declaration also, whereas declaration will give you only, it will tell you such a type of variable is already available. For example, if you say extern int a, it tells you that such a variable is available. It tells that such a variable is available. Here it won't create any memory, sir. Suppose there is a global variable like int a, here the memory is created. When you say extern int a, you look for this variable which is already defined. You are using that, my dear friends. Second point. Yeah, I'll give you once again. See this, sir. The variables that have to be used by many functions, even in different files, they are to be declared as external variables. Okay. And here there is a difference between declaration and definition. See, normally declaration means you just tell the type and name of the variable. Definition means not only type and name of the variables, memory is also created. See, when you create memory, that is definition. When you only say this type of fellow is available, that is declaration. For example, you see function prototype, that is declaration. Function definition is activity of the function. Similarly, for variables also we can have definition and declaration. That definition and declaration difference you can only understand for external variables, because for all other variables, definition and declarations are one and the same. Whereas for external variables, the definition and declarations are different. For example, if you are having a global variable like int a, this is global variables by default are external variables. You don't have to write anything, sir. It is by default external variable. Suppose if you want to use this in some other files, for example, this file name is file1.c, sir. This file name is file1.c. I want to use this variable in file2.c. I want to use this variable in file2.c. Of course, I have to include this file1 f1.c. Then I have to say that extern int a means this a is already defined somewhere. I am using it. It is already there. I am using it. You are just telling the compiler that Babu, I am not defining any memory here. This fellow is already available. Use that only here. Use this variable here. So it may be available in F1 or it may be available in the same program. Okay. So when you include that particular file in your program, suppose in that particular file this integer variable is available, that will be used. For example, you not defined here. If you say this, it will be error, my dear friends. Of course, it won't be error. If you use it, then it is error. For example, int a is there, you can use it. Int a is not there, you are just mentioning, because declarations will not give you any error, my dear friend. But suppose if you do a is equal to 10, and if such a variable is not there, then it will be error. Please note that point, my dear friends. Am I clear? See what this tells you. It tells you in this file or whatever included in this particular file, in those files you can find this particular variable. It only tells you that. Am I clear? Suppose file 1 you included, in that int a is there. This a means this int a, my dear friends. And now if you want, you can say a is equal to 10. And suppose this int a is not there in any of the files. A is not available in any of the files. You just declared it. No problem. Up to declaration, no problem. But if you use a is equal to 10, then because you are using it now, it will search for that particular integer variable. It is nowhere available. It will say, Babu, where is that file? Where is that particular variable? You will get an error, my dear friends. At that particular point, you will get an error. So please be careful, my dear friends. Am I clear? So there are two parts for this external variable. One is definition. So generally in the file, the global variables are default external variables, my dear friends. And they can be directly used within the file anywhere. If you are using in other files, you have to mention that extern keyword, my dear friends. You have to use that extern keyword, my dear friends. Hope all of you understand this. Is the idea clear or any doubt? Ashpreet, anyone having doubts, sir? Please tell me. Sir, for importing a variable, should that variable be declared outside the function in other C files? Is it possible to import a variable? No, generally it should be outside, sir. No, it cannot be inside a function, sir. Because within the function, the scope will be within the block, sir. It should be global variable there. It should be global variable, sir. It should be global. If it is within the function, its scope is gone. Within the function, its scope is gone. You cannot use it, my dear friends. Am I clear? See, extern, which is global, that can be used within the block. But whatever is within the block cannot be used outside the block. Whatever is within the block cannot be used outside the block. Okay, it has to be global variable somewhere. It has to be global somewhere. Got it? Now look here. This is a global variable and you want to use in this file or somewhere, you can use this. This is declaration. This is definition, because here memory is created, sir. Memory is created. And you know memory is created in data segment. Memory is created in data segment, not on the runtime stack. For these global variables, memory is not created in runtime stack. That is created in data segment. See, in data segment, I told you two parts. One is initialized data segment, uninitialized data segment, BSS segment we said. So there this particular variables will be stored, my dear friends. Am I clear? There it will be stored, data segment, not on the runtime stack. Not on the runtime stack, my dear friends. Now let us try to understand this difference between definition and declaration. See, definition creates the variables. Generally, these are global variables, my dear friends. Simply, they are global variables. Memory is allocated when program begins execution and remains allocated until the program terminates. So, global variable when you create, the memory is allocated in data segment. If it is uninitialized data segment. If it is initialized data segment, the memory is created, my dear friends. And it will remain till the program terminates. This value persists between function calls, or value persists between the calls of that particular variable, my dear friends. Am I clear? there can be only one definition. We define it only once. We define it only one time. The variable can be initialized with definition, and initialized should be constant. See, for example, this definition, whatever you given, no? You can give this definition like this, or you can give this definition together with initialization. Initialization you can do with any constant, my dear friend. Only constant can be initialized to it, not an expression. You cannot initialize with expression. It should be a constant. You should initialize with a constant. This is allowed. This is allowed. Actually, for this global variables, if you uninitialize also, by default it will take the value 0, my dear friends. By default it takes the value 0, my dear friends. The keyword extend is not specified in the definition. See, in the definition you don't write extend, sir. Only when you are using somewhere, there you have to mention extend. Means, when you mention extend means you are saying that this variable is defined somewhere, use it. This variable is defined somewhere, use it. For definition, you don't write extend keyword, sir. For definition, you don't write extend keyword. You write extend keyword only when you use it somewhere or when you declare it. Got it? The definition can be written only outside functions. As someone asked me this question, Eddie, your doubt is cleared with this point, my dear friends. Your doubt is cleared here. Correct or not? It has to be declared outside all the functions. The definition must be outside of all the functions. They are global variables. They are global variables, my dear friends. Got it? Now, declaration. The declaration does not create the variables. It only refers to a variable that has already been created somewhere. So, memory is not allocated at the time of declaration. So, when you say extend int a, what does it say? Maybe in this program, or maybe whatever is included in this particular program, the files, in that you may find such a variable. It tells you such a variable is already defined, use it. And you should not initialize here. Of course, after this you can modify the values, but here you should not write like this. This is error. You cannot initialize here. This is declaration, not definition. You cannot do any adding values or doing assignments and all. You should not do it. Am I clear? There can be many declarations. There can be many declarations. The variable cannot be initialized at the time of declaration. As I told you, you cannot do this. When you are declaring, you cannot initialize it. The keyword extend is always specified in the declaration. Here, keyword is compulsory. Keyword is compulsory, but within the same file, even if you don't write, default extend keyword will be supplied for that particular variable, my dear friends. Am I clear? Of course, you don't even have to write it, sir, but it would be taken default. I'll explain that with example. The declaration can be placed inside functions also. See, definition of extend variable, they are obviously definition in the sense global variables are default external variables, sir. Their declarations can be inside the functions. Definitions cannot be inside functions, but declaration can be inside the functions, my dear friend. Am I clear? Now, storage, where it is stored? In the data segment. Data segment are stored, not on the runtime stack. Uninitialized, suppose if you don't initialize it, default value for them is 0. Default value for them is 0. No, that is fine. Extern int, int a also you have to write. You have to write extern int. What is that int? You have to say no. Then you can write a is equal to 10. Then you can write a is equal to 10. This is fine. This is fine. A also you have to write. You missed this, sir. This also need to be written. Okay? Arshpreet. Okay. Now scope, global. It can be used anywhere. Accessible to all functions and all parts of your program. Everywhere it is accessible. Lifetime of the program. How long it is available, sir? Lifetime of the program and till program ends. So these external variables, global variables are available everywhere of the program, my dear friends. Even they can be used in other files also. You can use them in other files also, my dear friends. Please note these points. Any function in the program can access and change external variables. Suppose you have external variable or global variable that can be accessed and modified by any function or any block of your program, my dear friend. But when local and global have same name, local and global have same name, the local will have precedence over the global variable. Suppose you have a global variable and within a block we have local variable. If you say a is equal to 10 means this a will be this a, my dear friend, not globally. This a will be this a, not globally. But if you write int a and within some block if you write extern int a, this means it is a declaration, means I am referring to the same a, I am referring to the same, it is not local a, my dear friend. When you say extern means it is not definition, it is same fellow I am referring to. I am referring to same fellow. So when you say a is equal to 10 means this fellow value will be modified, my dear friends. This fellow value will be modified. Now one more thing also we can note it, my dear friends. Suppose if you have int a and you have some function, and in that suppose if you put a is equal to 10, because within the same file in any function if you are using a and there is no local a, this a you don't even have to write this extern int a, sir. Automatically they are considered as extern int a only, even if you don't declare them within the file, within this particular file. A can be used anywhere, sir. It can be modified, it can be changed, you can do that, my dear friend. No need of writing extern int a. If you write, there is nothing wrong. Without writing also you can use them. Without writing them also you can use it. But in other files, generally when you are using this in other files, there you have to mention extern int a, my dear friends. There you have to mention extern int a, my dear friends. I'll discuss that ID, I'll discuss that example also. I know that your doubt. I'll discuss. If you you copy paste that your doubt, after completing that particular doubt, if you still not clear, you can ask me. Okay? Yeah. Sorry. Now look here. What happened to this? Yeah. Yeah. Every byte of memory allocated for external variable is initialized to 0. Every byte of memory. See, for example, there can be global arrays also. So all the bytes. Suppose integer variable is 4 bytes. Every byte is allocated with 0. That is what you mean by initializing with 0 means all the bytes are allocated with 0, my dear friends. That is all zeros. All zeros will be stored. Am I clear? So that is the point to be noted. This is one more important point, my dear friends. Please note it. This is important point. This is also important point. They can ask you this in GATE examination or in a interview question, my dear friends. These are standard interview questions. So when you say that default is 0, okay, 0 is stored or every byte is initialized with 0. That is every byte. For example, if it is array, all that array elements are initialized with 0, my dear friends. That is the point to be noted. So let us take one example. You have global variable, of course, hash include also you can write, sir. Main function. Some nonsense. Function 1. Now this a is available inside this. Here I can use this a, I can use this a. If you want to use a, directly you can use it, or if you want you can say extern int a and you can use it. Without writing this also you can use it within the same file. Even if you don't write it, by default it is considered as extern int a, my dear friend, and this a can be used, my dear friends. A can be used or available for all the functions. A is available for all functions. Let us see this example. Now here, this is a local A. This is a local A. This is a global A and local A. Which one will get preference? Which one will get preference? Global or local A? Is it local A or global A? Can you write the that also that I'll tell you that is important, that point also I'll tell you, that I'll tell you. Abhay, I'll tell you that. Local. This A is local, my dear friend. I'll come to your doubt. Yes, interesting doubt. That is interesting doubt, sir. I'll tell you that. A is 10 means this A is 10 means this is local A. This A means now when you are using A, it is not referring to global A, my dear friend. Suppose if you are having local fellow will get preference, not the global fellow. Am I clear? Like that. Now here, this A is equal to 1 is what? This A is equal to 1 is this local A or global A? This A is equal to 1 is what? Local. It is not local, sir. It is global A, because there is no A inside the main. Inside the main function there is no A. So this is global A. This is local A. This is local A. And you call the function. Inside the function, this A means this value of A, my dear friends. Am I clear? And when you print A, see, I am saying print means printf, my dear friends, simply calling it as print, okay? Printf function. And when you print, this A value is what? What will be the value of this A? It is just a pseudo code, my dear friends. What will be the value of A here? What will be the value of A here? Is A value 1 printed or 10 printed? What will be printed? Suppose if I use printf function, whether A is 1 printed or 10 is printed. Abhay, see this carefully. A is 1, this is global 1. Am I clear? Now you call this particular function, so you entered here this local A value is updated to 10. This A value 10 is gone once this function is gone. See, it's like this. You have main function, and you have this function. And main is using global A, that is stored in data segment. This A value is stored in data segment. Initially it is 0. And inside this A value is updated to 1. Then you call this particular function. In this there is a local A whose value is 10. But once this function is gone, this entire story is gone, my dear friend. This entire story is gone. Now this local A is not available anywhere. Local A is not available anywhere. Only A means this global A only. And what is the value of this global A? 1. 1 is printed, not 10. 1 is printed, not 10, my dear friends. Very good, very good. Is that clear? Now look at this. The one which you asked, Abhay, you asked now, that I am going to answer now. Int y, main, y is equal to 5 is external. Suppose if you print this now, printf, if you do it, you are going to get 5 answer, my dear friends. Now look at this example, my dear friends. Look at this example. Okay, here it is global x, and there is a main function here x equal to 10. So it is global x only, because there is no x here. So this x is global x. And I print the value of x, I get 10 value, my dear friends. Then I call function 1. Control passes here. Now I am doing it extern int x. Extern int x means this is also referred to same x. So the same x value, actually x value I write it here. Initially it is 0 here. Once it comes here, it is 10. Now the value is updated by 10. So it becomes 20. And I print 20 is printed. Once it is done, I move back here. Now function 2 is called. So control moves to function 2. Now here we have global x. You have local x. This is local x. Okay. So this is a local x, my dear friend, and whose value is 1. And when you print, you will not get 20. You will not get 1, sir. Okay. You will not get 20. You will get this one because it is local x. What is the local value of this x? 1. 1 is printed, my dear friends. So 10, 20, 1 will be printed for this. 10, 20 and 1 will be printed for this. Very good, Eddie. Very good. Yes. So when it is global, here you see I not use this extern int x, but still it refers to the global only. Here I written extern int x. Here I did extern int x. This is also fine. See, without using this also you can do this, sir. Actually, This particular statement is not required here because it is in the same file. No, even if you don't write it, automatically it will take this particular value only, my dear friends. Automatically it will take that particular value only. Please remember. And one more important point, don't initialize value here. For example, some people are in hurry, they'll do it like extern int x equal to 10. This is wrong. This is wrong. Don't do it. Don't do initialization for extern declarations. Don't do initialization for extern declarations, my dear friends. Hope you understand. Hope you understand. So this is the output, my dear friends. Now someone asked me this question. What will be output for this particular program? What will be the output for this particular program? Someone asked, now after main they want to write int y. After main they want to write int y. So I am answering every question. I am prepared with every question, sir. I am answering all your questions. Okay. So if you detailedly follow this particular notes, all your doubts will be clarified, my dear friends. Output is 5. I think Eddie you asked or Abhay you asked. Who asked this question? I didn't remember. But see, my dear friends, here int y is defined after the main. So when you enter this fellow main do not have idea about this main do not have idea about 5, it will give you an error. It will give you an error. You see, this is what happens. It says y is undeclared. Y is undeclared. Because y definition is after main. So before the definition if you use it, it will say who are you? It will say who are you? So if you want it to run properly, if you want to use it, why? Then what you should do? You do this. So now what happens? Y is defined later, but what you mentioned? Extern int y, such fellow is available, check. So it will check the entire code. Now you get the value of y, my dear friends. So if you want to write the variable definition after the function and you are using that particular variable within your function, you have to use this extern int y, my dear friends. You have to use extern int y, my dear friends. Hope you understand. Yeah, now it should be 5. Now you will get the proper output, my dear friends. Because I not written only y value I am printing, na y value is printed. If you put y is equal to %LD, y is equal to 5 will be printed. Correct. Super. That's it. Now comes the most important fellow, static. Okay, let me complete this. Now this question someone asked. Let me answer this. If the program is in several source files and a variable is defined in file 1 and used in file 2 and file 3, then extern keyword must be used in file 2 and file 3. See, within the same file, if you want to use extern, no problem, sir. If the variable is defined global, after that any number of times you can use it without using extern keyword. But if the if the variable is defined in one file and you are using in other files, extern keyword is compulsory. Yes. I think you are answering for previous one, Sujim. We are moved little ahead. Now look at this. Here I am having int a, which is global declaration, and a value is 10, my dear friends. Now in file 2, if I want to use this a, I have to write extern int a. In file 3, if I am using this, I have to use this extern int a, my dear friends. Yeah, you have to include this file, sir. You have to include this file. Yes, you have to include this file. We are access this using file 1. Now suppose in this there is a function. Here extern keyword is not necessary. If the definition is before the function, extern keyword is not necessary. Even if you write, there is nothing wrong, but not necessary. In this, extern is not necessary. This is not necessary. Not necessary. But in other files, it is compulsory. No problem. Import means then import file 2.c. Then this file 2 should be included here. Na? See, same as file 1 you are including another files, or file 2 you are including file 1, same story, na? What way it is different from that? It has to be same. Yes or no? See, any file, sir, file X, you want to include file Y. Whether you are doing in file X to file Y to file X, what is the difference, sir? Story is same, na? Time ho gaya, but I not completed even static, sir. Shall we do static tomorrow? Nothing will happen, sir. Here this value is A is 10. If you use, suppose A is 20, this A value 20 ho jayega. If A is 30, A value 30 ho jayega. Suppose you use A is equal to A into 20, 30 into 20 ho jayega. That is what happens. Okay, so storage classes I thought of completing today, but I think we delayed. I don't know how it went. We taken too long today. Okay. Up to here it's clear. Up to extent is clear. Yeah, tomorrow we'll continue with storage class. Then we'll continue recursion also tomorrow, sir. We'll continue recursion also tomorrow. Tomorrow we'll do it. Got it, sir. Very good. So static variables we do it tomorrow, sir. Static we'll do tomorrow. As time is up, some people are mentioning. I thought it's only 9. Sorry for that. I haven't seen the time. Tomorrow we'll continue, sir. Tomorrow we'll continue with static, and that is most important one. Static is the most important one, sir. Okay. Is that clear? Is that clear? And please do this particular, subscribe, or what you call this. Join this particular Telegram group for notes and regular updates, my dear friends. Am I clear? Thank you.